Hello, everyone, and welcome to our webinar on agentic data engineering, where we're going to show you how we take data workflows from manual to AI powered. Today, I'm joined with Sean, our founder and CEO,
Hi, everybody. Great to meet you all. Thanks for joining us today.
and also presenting with us today is Cody, our product manager.
Great to be here. Excited.
I'm Shifra. I'm the DevRel advocate here at Ascend. And the last friend joining us today is Otto. You can see him. He's the goat on the rocket in the top right corner. And he is our agentic intelligent data engineering agent who is embedded in every layer of the platform, which we'll talk a lot more about later. But first, let's get into today's agenda. Sean is going to walk us through the current state of data engineering and how we got to this point in the landscape. Then Cody's going to do a deep dive into how these agentic systems actually work. Then I'll be giving you an agentic data engineering demo so you can see all the cool agentic data engineering features that we have to show you. And finally, we're going to do some Q&A at the end. So please submit your questions at any time, and we'll get to them for our last segment of the agenda today. Sean, I'm going to hand it off to you, and really excited to hear you walk through the current state of data engineering.
Amazing. Thanks for kicking us off, Shifra. Honestly, I'm even more excited to get back to Shifra's section at the tail end here, as I think it's really the most exciting part we have for today. And so really, as we work our way through the agenda, I just want to lay a little bit of a foundation layer, talk higher level around what we're seeing in the industry, some of the evolutionary trends, but pretty quickly get into the details and the nuances around agentic data engineering. Hand it off to Cody, who will take you even more deep into it. And then we're going to get to the really exciting stuff in the latter half. But before we get too far into it, I always like to start with teams that really do a little bit of a self-reflection of, look, we're all here because we love data engineering, but what kind of data engineering are you really doing today? As I've worked with a lot of data engineering teams over the course of time, same reason why I got into data engineering, gosh, almost 2 decades ago now. It was for the things on the left. We're pioneering, we're doing super exciting things with data. We're powering machine learning, data science, analytics, really fueling the future of our industries, of our business. And we're getting to solve some really exciting technology problems at the same time. Yet a lot of the time, the reality is we feel like we're a lot more of the team doing the thing on the right-hand side, which is plugging in a bunch of systems, trying to keep data flowing properly, constantly integrating things. And I think data engineering, more than many professions we see, is saddled with a lot of toil, just a lot of manual work and effort that can really actually slow us down and takes away from a lot of the really exciting things and the really compelling and powerful things that data teams can do. And the reason why I like to highlight that too is if you also feel that way, you are not alone. Every year, Ascend runs an annual survey. We ask open questions out to the broader industry. How busy are your data teams? Are they over capacity, significantly over capacity, just slightly over capacity? And one of the things that we notice and continue to see is that only 5% of data teams report having any extra capacity. And one of the really key parts of that is when we think about how critical future adoption of AI is, your data teams are the most poised to really have some tremendous impact around AI adoption and even more importantly, driving AI work inside of the business itself. Yet, if your team, only 1 out of 20 has any capacity, this makes it pretty darn hard to take this incredibly talented and resourceful team that's very familiar with the data and have them do really powerful things with AI because they just don't have enough time in the day. And why I think that matters so much is I actually see today that data teams are falling behind software teams, marketing teams, support teams. And I think that's a bit of a travesty. And while we watch a lot of the other industries, we see software engineers are finding tremendous adoption around AI and agentic workflows. They're writing more and more and more code directly with AI. Marketing teams are reporting amazing results with AI. Support organizations, same thing. You name it. Most functions, most teams, most roles are really finding these incredible results and performance gains. And so this really begs the question then, Why is data engineering so far behind, and how do we actually fix that? And the big thing that I would like to pose is we've all seen this slide. Well, I assume most all on the webinar have seen this slide before, and it keeps getting bigger and bigger and bigger. The number of companies and technologies and tools in our space is astronomically large, and that's great and that's exciting, and it means we have access to far more capabilities than we did 2 years ago, 10 years ago, 20 years ago. But what it oftentimes means for us and our teams is that we're spending a lot more time over here on the left, basically connecting things and plugging them together and wiring up systems, as opposed to creating data products and innovating with data and creating really compelling, exciting new experiences. And so that's one of the big areas of focus for us, both at Ascend, but just as an industry as a whole, is how do we get people doing a lot less plumbing, and how do we get people doing a lot more innovating? And so when we think about how is agentic data engineering going to help us get there, there's a few things that I would like to pose just as a structure before we get too deep into it. The first thing that I really want to encourage folks to think about is AI can truly participate in the entire DataOps lifecycle. I think oftentimes, when we think about AI and agentic things today, especially as developers building products, we usually tend to think about it for things that are more in our dev experience. Help me write some code, maybe write some documentation for me. But when we think about this holistic data ops cycle, everything from building code to deploying it, observing how it behaves, all the way back to that continuous feedback loop, no different than what we've seen in the DevOps cycle. Agentic capabilities and AI really can play a key and pivotal role in this entire cycle. What does that actually mean? And what does that even look like for today? This is where I really want to pose, I think, a reset for folks, and to really demand and think big about what AI can do even today with today's exact capabilities. Is, yes, of course, a lot of these things we see on the top here, we know AI can do. Most of us have probably used a ton of ChatGPT or Claude or a lot of the other services, or we use Cursor or Windsurf in some development experience. We know AI can answer questions and do research across our code base. We know it can write documentation and tests for us. We know it can even actually help us build and find errors and fix bugs for us. But one of the other areas where I really like to encourage people to think and challenge themselves on too is AI can do a lot more, especially when we take agentic workflows and we put them into a broader space. And they can start to do things that oftentimes are the toil and the highly disruptive toil we end up exposing our data teams to. That's things like monitoring pipelines for performance and breaks, optimizing our resource usage to keep our overall cost down low. It's also things like migrating platforms. The bane, I think, of every data team's existence is how much time and energy it takes to move from one platform to another. AI is increasingly good at these things, and even today, it's already capable of solving a lot of the pains that developers experience in this domain. Now, it doesn't come always easily. It takes work to get there. So I wanted to give a little bit of a framework to how at least we think about this at Ascend, and how have we tackled some of these problems. We think about it really in this three-pronged approach. First and foremost, you got to have a ton of metadata. You got to collect all the things so the AI can operate on it. And then more importantly, too, and Shifra's going to show this in the demo, you need an ability to have an automation system that can trigger AI and help it connect with other parts of the outside world. Cody's going to go through a little bit of the agentic architecture and how that works with things like MCP servers and tools. But then you'll get to see some of this in action and live in Shifra's demo as well. Now, when we talk about things like metadata, that means all sorts of things. That means things like your code, the underlying data, user actions, what's happening inside of your infrastructure, lineage and dependencies, you name it. If it's something that you as a developer interact with, you generally want to get that exposed to AI so that it can do the same things and offload increasingly large blocks of toil from you. And so combining that with what we were talking about before, this is really where we see those incredibly powerful capabilities, where combining that unified metadata with the AI agents and that ability to both trigger in and interact with the outside world in response to all sorts of changes. It's those pieces combined really help connect this entire agentic DataOps lifecycle. And before I hand it over to Cody, I did want to just remind folks of three things that I think are really important to embrace here. First is, I think probably why we see so many people so excited to attend this webinar. Most people have generally embraced this. We're seeing general purpose, not even data engineering specific, just general purpose AI capabilities are doubling every 3.4 months, which is roughly 11.5x annually. We are seeing connectivity standardize very, very quickly with technologies such as MCP, and this is accelerating adoption significantly. And when we combine the surge in capabilities with the surge in connectivity, this is a really exciting time for agentic data engineering. As one of my friends, I love the saying he has, which is, just think about the AI you're interacting with today. It is the least sophisticated you are ever going to experience going forward. These things are getting so much more sophisticated so quickly that there is no time like the present to start taking advantage of these, getting really familiar with what they can do and taking advantage of it, because in a blink of an eye, they get better and more helpful and more sophisticated. And it's a very exciting journey to be part of. Now, with that, let me hand this over to Cody, and he'll start walking us through how agentic systems work.
Awesome. Thank you, Sean. Yeah, as Sean mentioned, this is a very exciting time to be working in data and AI. I've had a lot of fun working on these systems that we're building at Ascend, and hopefully I can teach you something or provide some insights into how do agentic systems work. I'm going to try to go through this very quickly, like less than 10 minutes, to give plenty of time for demos and seeing it in action. So feel free to ask questions or reach out after the webinar if you would like to go deeper or get any links on this stuff. But let's dive in. So let's start by trying to define what exactly are AI agents. A bunch of people have come up with their own definitions. I have my own snarky one, which I'll spare you in this webinar. But a common technical one that engineers are landing on is an agent is a for loop with an LLM call. That's pretty simplistic, but as it turns out, this simplistic model is very powerful for what LLMs are able to achieve. Now, this isn't a unique realization. People have been doing this thing for years, at least two. Back in 2023, a bunch of people had been trying these kind of things, but they didn't work as well then. So that isn't interesting to think about. As Sean just mentioned, the capabilities keep improving at a rate where you can put an LLM in a for loop and just make tool calls and get pretty useful activity out of it. So we're going to build up to this very quickly. This might be a little boring if you're already familiar, but underlying technology that allows you to do this is an LLM's ability to turn unstructured text into structured data. So you can force an LLM to produce structured output. Usually that's in the form of XML or JSON, and that lets you basically have typed data that you're extracting from your text. This is super, super fundamental to understanding how these tool calls work, because you're able to, have a user input text, have the LLM extract out the pertinent information from that text, and use it to make a function call. So a tool call is basically just that: text into an LLM, extract out the data, pass in that data to an arbitrary function call, and then that function can go and do whatever, whether that's writing a SQL query, executing a SQL query, just getting information about a user, really any arbitrary thing. And that function will probably return some data, including things like the status of what it just did. And this is where it becomes really clear that you can start to do this in a for loop, passing this data back into the original text or into a prompt, into the LLM, and allowing you to build up to this agentic behavior. Okay, we're on the same page. We understand that we can take an LLM, put it in a for loop, and this is kind of what we refer to as agents. It's important to understand, as Sean alluded to, that these agents are acting in an environment where they need to be able to access context and make calls to a bunch of different tools. So here we can split this out to a user interface on the left. Often this is a chat window, but it's really important that this doesn't have to be a chat window, right? This can be email, this can be Slack, this can be a GUI with buttons. There are a bunch of different ways you can construct this user interface. But at the end of the day, usually you're going to have some sort of text that you're feeding into an LLM. You instruct that LLM, hey, you are an agent, you're acting in this environment, you have access to these tools. That agent now can go and pull out data, pass into a function, get data back, and act on it. And this is the agentic for loop that really defines how all these systems fundamentally work under the hood. Again, gross oversimplification, we're going through this very fast. But this is kind of the same thing that everybody is coming to when they're building these AI agents. So one of the cool things to note is, again, these functions are arbitrary code execution. So you can do things like even call LLMs or even put an entire agentic loop within your function call. So you can have an agent that has access to tools that in turn call more agents. This can get arbitrarily complex, and a lot of the art or science of building up these agentic systems is how you manage that complexity and give the agents both the right tools and the right context within this environment to take useful actions and really achieve useful outcomes. You'll more often see this kind of diagram formulated like this. And if you actually go to build agents yourselves, you'll notice that all of the various language SDKs, whether you're using OpenAI's or Gemini or Google's or somebody else's, they all tend to look the same. You initialize some agent object, you give it a system prompt that again says you're an agent, you're in this environment, you have these tools, all of their additional details, and then you kind of hand it a series of tools that you want it to be able to use and give it the ability to do these things in a loop. So once again, taking a step back, you have your user interface. You now have this thing that we don't really refer to as an LLM. It's now an agent that's able to achieve some higher order of tasks. You give that agent tools so that it can complete those tasks. And now you have an agent in the modern sense that we are talking about it. It's again important to note that these tools and data that the agent are accessing through, again, going back arbitrary functions, can be anything. So this might raise some red flags. Obviously, if you're thinking about enterprise security and data, which I'm sure we all are, and we do need to deal with those things in these agentic systems. And that's another point that becomes very important as you're building these things. Just to give an example of what this might look like, often people say, well, we have these agents now. Can't we just have an agent that goes and answers questions like how much revenue did we make last month? Or what are our weekly active users? So you can imagine a user interface on the left. This could be a chat window. This could be, you could email this thing, bunch of different, pretty much infinite options. Agent is sitting within some environment that has access to your organizational data. It has some tool to go query metrics about your revenue. It has some tool to go gather user context so it knows who's sending this query. You don't have to bootstrap the prompt and say, my name is Cody, I'm a product manager, all this other context so that it knows what to go do. It knows context from the environment that it's acting in. So you give these tools, it can get information about me, it can get information about our organizational data, and then it can have a tool to go and answer the user. So this is all really, really cool. Would love to go even deeper and talk about this more, but want to take a step back and bring us back to like, what does this mean for data engineering? What does this mean if you're building products around this? So agents certainly introduce a few problems. The first one that we have to stare straight in the face is non-determinism. When you put text into a LLM, you are not necessarily guaranteed to get the same text out. There are ways that you can deal with that, but as you chain more and more LLM calls and build more complex systems, This is really just something you have to deal with, that outputs are not necessarily deterministic. Turns out not to be a huge big deal, as we'll see in point 4 as a spoiler alert. Common adage in machine learning, right, is garbage in, garbage out. The agent has to have useful context. If you want the agent to be able to compute your revenue accurately, you need to have good data that it can go and query, or ideally even an API where it can ask what the revenue was last month. The cool part is that you can increasingly use agents to go and build these clean data pipelines and establish these best practices. But you do need to have a good set of foundations for agents to operate appropriately. With that, you need to think a lot about the context that you're giving it, not giving it too much context, not overloading it, a bunch of technical details on how different providers and specific LLMs handle this stuff. But you need to think about those. You need to think about the feedback loops that you're constructing. We talk about this a lot within Ascend. Constructing good feedback loops so that the agent can go and know that it is improving or making progress toward the goal that it is set on. And then finally, data and access controls. This one seems pretty obvious, right? You don't want your agent that can run SQL to have access to prod and be able to run drop table. These are all pretty basic when you frame them in the broader context of a data platform. And it turns out you just treat agents just like users. You give them permissions and roles. You basically have service accounts for them. And that's how you're able to safely isolate development environments from production environments and so on. So quickly, before I hand it off to what we've all been waiting for, the awesome demo, I want to talk about how is this evolving. So as Sean kind of mentioned, developers, software engineers today, myself included in this, are increasingly offloading tasks to agents and frankly coding by hand less and less. The amount of things that I personally, and I know tons of other people, are able to accomplish with these tools, Claude, Codex, Cursor, all of these different agentic tools. One just launched again from Gemini today. We're able to achieve so much more and offload a lot of the monotony onto agents, which is awesome. The second, as Sean mentioned, models have gotten so much better. So if you tried to go build this 2 years ago, there was nothing fundamentally stopping you from doing it. It just did not work nearly as well as it does today. And with that, we're seeing the emergence of standards and best practices. One of these being MCP. So instead of having different protocols for how you define tools, there's an emerging standard called MCP that just lets you go do that and is pretty usable across different AI frameworks. So let me wrap it up quickly here. We started with this definition that an AI agent is a for loop with an LLM call. I say that's technically true, but the better way to frame this and think about it as a user, as a data engineer who's doing agentic data engineering or a software engineer, is that an agent is really a context-aware actor, right? It's operating in some environment. It has access to things in that environment and knows what is around it. It achieves outcomes. So you set it on some task, some meaningful thing that you want to get done, and it's able to do that autonomously. So with decreasing human intervention, needing to go through a chat interface and have a bunch of back and forth. So this is kind of the useful definition of AI agents that we're landing on for data engineering. So to summarize, or frame this in terms of what you need to accomplish this in an agentic data engineering platform. Effective use here will really acquire access to the same context a data engineer has. If you want an agent to perform well, it needs to have all context. The ability to operate autonomously, so that's setting up permissions and roles and making sure that things are isolated and going to work well. Ton of guardrails, permissions, and access controls with that, the ability to do rollbacks, all the kind of standard things that you would want in a data platform, which leads me to really, you need a solid data platform. An agent operating in a cobbled together or very hacky stack isn't going to do a ton better at figuring that out than a human is. In fact, it's probably going to do a lot worse. This is a concept we actually refer to internally to some extent as like the AI Trojan horse. If it's hard for an AI agent, it's probably also hard for a human who's coming into something without a lot of context and background. So you want to have solid foundations. And then finally, you need to build delightful product experiences around this. so that people can enjoy the time they're using these agents and really get the most out of their usage. So with that, I will hand it off to Shifra to demo the agentic workflow that we have built into Ascend.
Thank you so much, Cody, for that awesome deep dive. And I think now that we've heard how we reach the current state of data engineering and what it actually means to use an agentic workflow, I think we're ready for an agentic workflow demo. So let's get it. So I want to show you all a day in the life of a data engineer with agents embedded in every layer, every step of the way. So the first thing we're going to show you today is that we can check Slack for updates from an agent. We can then investigate an issue that was identified by that agent. We can then collaborate with the agent to patch the issue and deploy the fix with software development lifecycle best practices and agentic commit messages all baked in. So more on that later. Stay tuned. Finally, we're going to convert an entire pipeline from Python to all SQL for a more SQL-based analytics team. So with that, let's dive into the agent update in Slack. So if I check my Slack right here, it looks like I got an auto alert that's telling me that the transform demo flow has failed again. The last 2 runs have both failed due to changes to the project made by me and Sean. And what I need to do here is review the latest commits and investigate any recent changes. So this is going to take us directly into our transform demo deployment. But I actually want to show you around the deployments dashboard in Ascend a little more here. So this is the main landing place for the deployments dashboard in Ascend. And this is our one-stop shop for end-to-end observability out of the box, where you can see recent runs, errors, automation, the deployment health here. And we can go into the transform demo flow that's actually failing. And I want to just see my DAG pop up here. Okay. And what we can see here is the entire transform demo flow here. So another thing that we can see in the demo deployment is we can see all the files that are going on here. And some of the really cool agentic stuff that we have in here is the auto notifications. And the reason I wanted to share this with you all is because the auto notifications are what we just saw in Slack, right? So how does that actually work? That's configured by us directly right here in these agentic automations. And this is empowering you to do so much more than just chat, which is what you'll see with a lot of different products. This is allowing you to get into your Slack, get into the outside world. And beyond that, we also have configured MCPs here. And this is giving you access to the entire world outside your Ascend environment. But it's also within your control, within your instance, completely secure. So another really cool thing about the deployments in Ascend is that even if I wanted to, let's say, edit this config here, this is actually read only. And that's because we're in a deployment, and that's indicated by the blue background here. So if we want to actually see what's going on with this transform demo flow that Otto told us is erroring, and we want to actually change that, we're going to have to jump into a development workspace. So let's do that. So if I jump into my development workspace here, this is a completely different interface. We can see that because the background is gray rather than blue. And that is that I can actually pull up this code and make edits. Not specifically that edit, but it's just a really good separation of tasks here where when you're in a deployment, you're just monitoring. And when you're in a development environment, that's when you're really working and changing things. So we enforce all of those best practices right here. So it looks like in this pipeline, it's the sales component that's causing all these errors here. And I can see a little preview of the run history here, which is really great. So we can see that it's succeeded in the past. It's been skipped a couple times, but it's erroring. And actually all the other components in the flow are actually doing just fine. But this seems to be the problematic one surrounded by a red error outline. So let's jump in and see what's going on in there. So I can pull up the code here, and then I can also pull up all of the component runs in here. So if I look at the most recent run, I can take a look at the error, and I could dig through this stack trace and see exactly what went wrong here. But what we want to show you is that auto is going to help me identify what went wrong. So I'm going to pull up auto error explainer with the click of one button, and then the auto side panel will pop up on the right-hand side. And we're going to see auto explain exactly what's going on. Auto's figuring this out. Just going to reload for a second here. There we go. Auto just took a minute. So one of the reasons that Auto is so powerful here is because it's fully context aware, meaning that it can see the metadata and the data that you're working with. So it knows what column types should be. It understands cardinalities. It understands the lineage of every single column that you're actually working with. And that's why Auto can actually explain what's going on in this error with full context beyond just like translating the error message to something more human readable here. So it looks like what Auto has identified is that we're failing some tests in this component, meaning that the unique store ID test is failing, meaning that the store ID column is not unique, and the count equal test checks that the row count matches an expected value, and that's also failing. So let's see if that matches what's actually in this error. So it looks like that's exactly right. Auto has correctly identified the error. And the next steps that Auto is offering me is reviewing the transformation logic, checking the definitions of the tests. And I don't have to say much here. If I want to check the definitions, I can just say 2, and it's going to go do that for me. So one of the other really cool things about Auto is that you can see what it's doing every step of the way here. So we can see the parameters that are going into Auto and the response that it's giving in real time as it's fetching these different rules and tools that it has access to. So now it wants a little bit more detail. So I think I'm just going to ask, do these tests make sense with our upstream data? And the reason I can ask this question to Auto is, again, because it understands the full lineage of our data and how everything has worked. And what Auto doesn't know yet is that I've planted these tests to see if Auto will figure out that they're not actually helpful. If we look into the actual component code here, we can see that we're looking for count equal 1, meaning 1 row in the result set. And that's obviously not what I want here. This table is doing a bunch of cool data engineering stuff, calculating total sales, defining 7-day rolling windows, and adding rolling sum and rank. So what we want here is for Auto to understand that these tests are not applicable at all. We don't want a unique store ID column, and we don't want just 1 row in the output. So Auto's going to figure that out for us right now. Okay, great. Now it's analyzing the component for sales. And it looks like it's waiting on a response here. But we can see that it's taking the correct path, the correct phone name, the correct component name. There we go. Getting the response in now. And it's saying that it understands exactly what these tests are doing, and the component is producing something completely different. So in the successful runs, we're producing 2,000 rows. So clearly we don't actually want the 1 row test constraint here. So Auto is saying these tests don't really make sense, right? So now that Auto has correctly identified the tests that I planted, I think we can safely say to remove these tests, please. Let's let Auto take care of that for us. Great. So we can see that it's going to be drafting these file changes. We can accept this change. And we want to save this change, actually. And now that we've saved our change, I want to take you into the source control panel, which lets you use all of the Git native and Git backed capabilities of the Ascend platform, all in the in-product development experience, which is super cool. So we can see that we have 1 change on the side. And if I open the Git log, going to take a moment to load here. If I open the Git log, we can see that I have a commit from less than a minute ago. But you were with me when I fixed this. I didn't write a commit message. What happened here is that Auto wrote this commit message for us to remove these tests for count equal and unique. And that's showing us that everything's going to be Git backed without us having to manually write commit messages, which is super nice. So I can easily merge this and promote it to my deployment here. And this is how you do software development lifecycle best practices in Ascend with just a single click. So let me merge that to a deployment real quick. So we're merging into the main branch, which is deployed in the deployment where we started. Awesome. So we'll let that merge. Our component is going to be totally fixed now because those bogus tests are gone. And then for the rest of this demo, what I want to highlight here is Auto's ability to really migrate code. And what we want to do here is take this pipeline, which is entirely written in Python, as you can see from the icons. we want to take this pipeline and convert it into SQL for a more SQL-based analytics team downstream. So I'm just going to say, convert this transform demo pipeline from Python to SQL. Let's let Auto take care of this for us and just make things easier for our SQL-heavy analytics team. Great. So another really cool thing about Auto is that it's going to typically make a plan and then ask you, like, should I execute this plan? It's not just going to start doing stuff. So you can really have visibility into exactly what it's planning to do. So now it's asking me, would you like me to create the new SQL file? And I'm going to say confirmed. And now Auto is going to draft those file changes. We'll see those parameters load up. We can see each individual change on the bottom here. And if we go back to our files panel on the side, let's watch all these changes happen. So it's going to delete everything here. So let's just accept all. We'll save all of these here. And it looks like we have a sales SQL file. We still have some other Python files in here. This is why you, the human, will always be important in the agentic feedback loop. This is why we always still need you, right? So I'm going to say, remove all Python files and replace them with SQL files. Great. So now it's taking some extra steps to list all the components and understand that there are still some Python files that need to be changed. So we're reading through all of these different Python components here. So the sales SQL is already migrated, but we still need to migrate the others. We're going to draft all those file changes. And here we go. This is what we want, right? So I'm just going to go ahead and save all of these. And you can see on the bottom here, it's deleting a bunch of stuff, which is what we want. So sales.py got deleted. We're adding a sales stores for SQL. And we'll just watch the rest of these come through. And we can see in the left panel here that these files are being changed. We got just a couple more to go. I think that's the last one here. And I'll just allow this change here. And now if I go back into my flow, we're going to wait for the build. And we're going to see all these new SQL files show up here instead of Python files. I really like, by the way, how you can save all at once, or you can go through each one and just click to see the code that it's generated, because that's going to help you a lot with doing things all in one fell swoop, if that's your style, or just being more meticulous with your AI-driven and agentic-driven development and just going through each kind of step on your own. And yeah, now we can see that our new setup has loaded here. And we can see that we have sales website, sales vendors, sales stores, and sales all in the SQL components here. So if I pull up the code, you'll be able to see that all of these are now SQL. And that is pretty much the demo that we have for you today of all of these different agentic workflows. With that, I wanted to thank everybody for joining. Feel free to ask any questions that you still have in the Q&A tab. And if you'd like to book our demo with our team, we would love to follow up with you. So please scan the QR code if you're interested in booking a demo. And with that, I think that we can go into Q&A here.
Amazing. I see a bunch of questions. Should we start tackling some of these here, Shifra?
Yeah, for sure.
Sakshi asked, what all tech does this work with? Would it Would it be able to work with Spark, Databricks, and Snowflake? Meaning, if it writes a SQL query, would it be optimized for Snowflake? The answer is yes. The Ascend platform works on Snowflake, Databricks, BigQuery, some other unannounced platforms that I know Cody is very excited about. And you do get some other added benefits too. Obviously, you get to benefit from a lot of the warehouse optimizations, but Ascend also has some built-in components types that are called smart components that for really large data sets, Ascend is able to better optimize. So you reduce the overall processing volumes that even get pushed out. So it's a pre-optimization layer. And then I'd say the agents are also very aware of the difference between views versus tables and when the pros and cons are to use each one of those in your data pipelines as well. And that can really help you further optimize your data pipelines and reduce the overall load on the system.
We had another really interesting question, and thank you for that. We had a really interesting question that I think is kind of tied to your AI development cycle, Sean. And I'm curious to know, how do you suggest evaluating and testing LLM responses to prompts, because it is kind of a non-deterministic world that we're working in?
Yeah, that's a really good question. I think there's twofold. From an Ascend platform side, obviously, there's lots of automation and systems that we have on our side to help ensure that the structure and the prompts that we have that we're injecting obviously work best with the workflows and the patterns that we're familiar with. Now, when it comes to you deploying your own capabilities, because that's one of the really cool parts about the Ascend platform is you can configure your own agents, give them your own directions beyond just a user prompt, but actually to a system prompt. And you can adjust their behaviors as well. And that gives you a tremendous amount of control, but it does open up the ability for you to even further fine tune those as well. And so when you experience those kind of workloads, we generally recommend trying those prompts and that tuning on multiple workloads and really taking advantage of capabilities like the dev to stage to prod promotion process we have in the platform to make sure that your agents are really performing well, first in your developer workspace, then in your deployments as you promote it through that lifecycle. And that helps ensure that as you're pushing these agents into production, that you're really evaluating them at material workloads and they're performing as you would expect them to.
Yeah, that makes a lot of sense. It's a new testing framework, just like new agentic frameworks, and has to match. I
Exactly.
think, yeah, no, totally. I think we can take this one to Cody. I'm interested to hear your thoughts on this one that we got from somebody. What are some of the real life use cases using agents that companies are implementing in data engineering? And kind of similar, but the person also asked, and how are they measuring the success of the model? I'm curious to hear some of the cool use cases that you'd want to highlight, Cody.
Yeah. In my experience with deploying machine learning, the best way to measure the success is usually on business or organizational outcomes. That's going to be very highly dependent on your needs and what you're doing. But you don't want to be in the state where you don't know whether the LLM or agentic solution you've deployed is working well, right? That's not a good place to be. So you do want to think about that from the front and have something good there. And so if you're thinking about that in the terms of data engineering, you really want to think about what are the things that data engineers do and what slows them down. So if your data engineers are constantly getting paged at 4 a.m. and woken up to go fight some fire, that's the kind of thing you can think about using an agent for. And that is the type of thing that we're starting to see people do. So have agents in the background that are looking out for those things that are going to go ping a data engineer and potentially grab a bunch of contests, go make a PR. So yeah, we're seeing a bunch of stuff. We're kind of seeing the evolution from just writing SQL and more simple one-off prompts to more of these agentic workflows that we're talking about.
Totally. And I think that alleviating pain is an underrated way of measuring success, where it's hey, do we not have this pain anymore? And it's not about passing a test or hitting a metric. It's just about making everyone's life better. Totally. Another question we got here, which I think I want to pivot a little from the question. Someone asked, can this agent auto-generate reports and charts from prompt? And that's not really what we do at Ascend. That's not really the core product that we offer. But I think what would be really cool would be to highlight how Auto can document data work. And Sean, would you want to talk a little bit about that?
Yeah, I think that, it's, as I alluded to earlier on in my slides too, Auto is really incredible at understanding your data, the workflow, the entire developer experience, and giving it access to the entire code history, who changed what, and how it's being used, and even giving when Auto has access to what's running in production, being able to write that documentation to really understand how your data pipeline and how that code, even in a developer workspace, is being deployed and used in production, and with what performance characteristics, is incredibly valuable. I would say, and kind of related to that, just grabbing one of the other questions that I see here really fast too, is on the can this be used for data profiling? The question is yes. We're careful about letting the agents and Auto, and specifically, run arbitrary queries on the underlying data plane. And we think that should be done very carefully. Auto does have the ability to look for data profiles, and more importantly, look for data profiles and pair them with code and performance data as it traverses the lineage of data itself. So understanding that whole life cycle of a data profile, how it's actually behaving and operating as it moves through code, and that whole life cycle is incredibly valuable. And Shifra had time just to really scratch the surface of that, but this is such a powerful and compelling part of that product experience that I do think is incredibly powerful once you can get your hands on it.
Totally. And I think we have time for just one more question. So I want to leave like a general question for Sean and Cody. We talked a little bit about feedback loops in Cody's deep dive presentation. Can we give some examples of what that looks like in the real world for people?
Yeah, I can give like the most basic example where I set this up all the time, which is like linting and formatting your code, or just having some basic unit tests. So if you have something that runs very quickly, you can give an agent a tool to go run something that validates your code. So it can edit the code, validate the code, and if it hits an error, you just feed that error back into the LLM, and it's able to kind of go work in a cycle and work through any build errors. So this is like really useful to get it to go do things that it might not have good context to otherwise, or otherwise deal with that non-determinism and like set it in a direction to go have some established outcome. So yeah, we find those super useful everywhere.
Yeah, and if I were to kind of build on that too, and I'm going to cheat because I'm going to try and get a 2-for-1 special, as I see 2 other questions. And sorry, everybody, there's far more questions coming in than we have time to answer, but I'm going to try and get 2 of you. The 2 questions were, then I'm going to tie it to Cody's too, so I'm completely cheating, is what would the migration path look like coming from Talend or dbt? And the other question is, how effective is Auto when you have little to no metadata? I think these are both great questions. They become really relevant, even as Cody was highlighting in this feedback loop, is oftentimes you start with little to no metadata. And the metadata you have is really just that spec for what a data pipeline could look like. If it's say, for example, a dbt pipeline, you have your dbt project, and you have maybe some Git history and what are pretty well-defined specs in the dbt parlance. That migration process, though, becomes really fun when you let an agent loose on this, as Cody highlighted, that feedback cycle where an agent can say, hey, this is my project. I know I need to convert it to an Ascend project. I know what the Ascend project scaffolding looks like. I know what the structure looks like. And freeing that agent to incrementally iterate, build the project, fix errors, and eventually get to a run state where it can then run the project, watch for performance behaviors. And what we're starting to see with some other really fun migration projects is even compare this data set with the original data set and troubleshoot and diagnose why maybe is the code different or is the data different itself. All of this becomes in the very tractable realm of what an agent can solve for, so long as you give it that feedback loop so it can continue to iterate and solve the problem, with the safeguards, obviously, and the guardrails of making sure it's doing it on dev data sets and things and safe parameters first before you let it loose on your production systems.
Yeah, I think that's some really good insight. And there is so much power in the systems around the agent. Like Cody talked about, how ML code is such a small part of the ML environment that the code runs in. It's the same thing here where the agent needs to be surrounded by all that context and all that metadata to really be super effective and 10x all of your workflows. So I think that's all the time we have for questions today. Thank you so much to everybody who participated and shared questions. We really appreciate it. And we're so excited to have you with us. And with that, is there anything else that we wanted to discuss or leave people with before we wrap up?
I think that's it. So everybody who joined us, thank you so much. Go forth, agentically data engineer, and hopefully we collectively are able to offload more toil for everybody and really get y'all into an exciting new era of data engineering together. Thanks, everybody.
Thanks, everyone. Bye.